Hello and welcome. Are you somebody looking to achieve one of the highest grades possible in GCSE Maths? Well, if you are, please continue to watch this session as we look to multiply and rationalise surds, taking our understanding of this topic of surds to the next level. Now, we always say that when we look at these more challenging topics, we will inevitably be calling upon your previous knowledge and your prior understanding. And in this session, we will certainly be calling upon your ability to simplify surds, but also your knowledge of expanding brackets, and also that general numerical understanding, that conceptual understanding of our number system. So if you are looking to achieve one of the highest grades possible, then please continue to watch this video. Well, as always, when I say we're going to start at a low level, I always refer to a relatively low level. Surds is certainly a more challenging topic, but the questions will get progressively more difficult, challenging, as we go through our 4 questions. So in this first question, we're just being asked to expand and simplify root 5 open bracket root 5 plus 2 close bracket. Now, some of you may be familiar with the notation root a times root a simply equals a. If you are, you might already know that we could write root 5 times root 5 equals 5. But I will do an extra step to my working out so that I add that extra level of clarity to our work. Root 5 times root 5 gives me root 25. Root 5 times 2 gives me plus 2 root 5. So what we're left with, very straightforward, this first question, square root of 25 is 5 plus 2 root 5. So we're just trying to build that clarity, build that confidence as we move on to the more challenging questions within this topic. So let's look at question 2. So straight away this time, you will note we have a double bracket. But the concept is exactly the same. As I've mentioned up here, root a times root a is a. You might be comfortable by writing root 7 times root 7 is 7. I'm going to take that extra step for the clarity. Root 7 times root 7 is root 49. Then I will have plus 2 root 7, negative 2 times root 7, minus 2 root 7, negative 2 times 2, negative 4. At this stage, I always like to do this step in a different coloured pen. Plus 2 root 7 minus 2 root 7 will cancel out. I've just noticed, for some reason, although I said it, I wrote a 2 there. I can then do some further simplifying, tidying up. The square root of 49 is 7, and I still have my minus 4. 7 subtract 4 is 3. Start looking at question 3 then. We're being asked to rationalise the denominator. Now, you may well have heard of us refer in previous videos to this word rationalise and rationalisation. The way we rationalise is to multiply by the numerator by the conjugate and the denominator by the conjugate. Because when we rationalise a surd, we're not actually allowed to change the size or the value of our starting term. We're just trying to rewrite it without a surd in the denominator. So at the minute, we have a square root in the denominator. We have root 5. We need to rewrite this fraction, but without a square root, without a surd in the denominator. And like I say, the way we do that is by multiplying the numerator by the conjugate and the denominator by the conjugate. So we'll get 4 root 5 over root 25 And that will simplify to 4 root 5 over 5. So you'll note we still have a square root in our new term, but it's in the numerator. So we have rationalised the denominator. 4 root 5 over 5. Finally, we're going to look at question 3. Simplify completely root 12 plus root 27 all over root 3. Now, in a previous video, you may have seen how we can simplify surds. And if you think about simplifying fractions, the way we do that is by looking for common factors. And I'm going to take that approach with this question. So let's just take the numerator. Root 12 does have a square factor. It's root 4. And to get back to root 12 would be root 4 times root 3. Plus, well, 27 also has a square factor. It's root 9. To get back to 27, we'd have to multiply that by 3. So we can write root 27 as root 9, root 3. And remember, we are still over root 3. I take my different coloured pen, and at this stage, I can cancel out my root 3's. So what am I actually left with? I'm left with root 4 plus root 9, which implies 2 add 3, which equals 5. So please, once again, if we have touched upon any topics or any understanding there that you think you might need extra help with, check out some of our other videos. But for now, the very best of luck in your quest to getting one of the very highest grades in GCSE Maths. Best of luck, and thank you for watching.